Hi, previously we talked about the curtailments of reinforcement bar in simply supported beam and also continuous beam. Using the simplified rules of doing the curtailment, today we're going to try an example doing the curtailments of reinforcement bar for a simply supported slab. We use the simplified rules as demonstrated in the diagram here to do the curtailment. Now, if you observe the simplified rules here, the curtailment for the simply supported slab as compared to simply supported beam, they look similar. Both are giving you the 100% amount of reinforcement bar at the midspan and then reduce to at least 50% of the reinforcement bar near to the support. Except that the locations where you are doing the curtailments are different. For simply supported slab, we are talking about 0.1 times the effective span of the slab, measured from the support. As for simply supported beam, it is 0.08 times the effective span of the beam, also measured from the support. Another differences between the simply supported beam and also simply supported slab is that the reinforcement bar that you are dealing with in the simply supported beam is one directional, which is the longitudinal reinforcement bar. As for the simply supported slab, you are talking about a flat member where there will be main reinforcement bar and the secondary reinforcement bar. This gives you additional considerations while doing the curtailments for the slab. Having the differences established, now let us look at the conditions when you can use these simplified rules for the curtailment. This rules is only applicable when the loads acting onto the slab is substantially uniformly distributed load. Otherwise, you cannot use this. Despite that, there are other considerations involved, which you need to consider the maximum bar spacing, which is slightly different from the simply supported beam. The beam, due to the smaller cross-sectional area, is more concerned with the minimum bar spacing. However, for the slab, the cross-sectional areas for the reinforcement bar is relatively large. Due to the large cross-sectional area, the slab is normally lightly reinforced. Therefore, the issue with the minimum bar spacing do not appear, but there may be issue with the maximum bar spacing. That's why for simply supported slab, you need to consider the maximum bar spacing. Also, you need to make sure the secondary reinforcement bar not less than 20% of the main reinforcement bar. And then consider the minimum bar curtailment. What is indicated here represents the minimum amount of bar to be provided. You can provide more, but not less. And then lastly, remember to round the dimensions to the nearest 25 mm. This is for the easy conversions between the SI unit to imperial units. 25 mm is equals to 1 inch. In the construction site, the workers normally use inches, which is imperial units, to do their work. However, as the engineers produce the drawing, normally the dimensions are presented in SI unit, which is in mm. As a result, to make the workers on site easier, it is recommended to round up to the nearest 25 mm so that they can make direct conversions from SI unit to the imperial units. Having the fundamentals established, let us look into the example. Given a simply supported slab here, the dimensions Ly and Lx 3 meters and 6 meters, and with the thickness of 150 mm. Assuming both Ly and Lx are simply supported, you are asked to do the curtailments for the reinforcement. First thing first, you will need to determine which directions it will be the main reinforcement and which directions will be the secondary reinforcement. For a typical slab, the main reinforcement it will be in the shorter span. Let's say this is the slab. This will be the main reinforcement. Whereas this will be the secondary reinforcement. Why is it so? Imagine this is your slab, which is being supported on all four edges. When subjected to the load, imagine how the members deform. Which side it will be more critical? You know that the bending will bend in this manner instead of going this manner. It is easier to bend in the shorter directions as compared to the longer directions. Why is it so? Because the longer directions you have longer span to restrain the deformations. Whereas shorter directions, the influence of this restraint over the bending at the center will be lesser due to the further distance away from the critical bending locations. Because of this bending response, we know that the shorter span it will be more critical. Therefore, main reinforcement bar it will be placed in the shorter span direction. Let's say now you've done the calculations and the amount of reinforcement bar required in the shorter span is H10 50, whereas the secondary reinforcement bar it will be H10 200. 50 is in fact quite closely spaced for a typical slab. Personally, I prefer to have the spacing of at least 75 and above. Now, if you choose to use bigger spacing, you can increase the size of the reinforcement bar with a bigger spacing of more or less similar amount of the reinforcement area. Let's say we stick to the initial arrangement, H10 50. First, you need to consider whether the secondary reinforcement bar is less than 20% of the main reinforcement. Let's say you increase the spacing and reduce the amount of reinforcement bar provided. This will be less than 20% of the main reinforcement. Therefore, you will need to increase the amount of reinforcement bar provided as the secondary reinforcement. For this case, we will stick to 200 mm. This will represent the amount of reinforcement bar at the midspan of the simply supported slab as the main reinforcement bar and as the secondary reinforcement bar. Next, we would like to check whether the maximum spacing is exceeded. There are two methods for you to check the maximum spacing, depending on the thickness of the slab. The first method is simpler, where the maximum spacing is already specified. This is applicable when the thickness of the slab is less than 200 mm. If the thickness of the slab is more than 200 mm, you will need a formula for you to determine the stress in the reinforcement bar. And then, based on the stress in the reinforcement bar calculated, refer to table 7.3n in the Eurocode 2 with the crack width of 0.3 mm. Determine the appropriate maximum spacing in accordance to the steel stress acquired. Coming back to this case, the thickness of the slab is 150 mm. That means we are using the simplified manner to determine the maximum spacing. For the main reinforcement bar, the maximum spacing it would be 3 times the thickness of the slab or less than 400 mm. As for the secondary reinforcement, it is 3.5 times the thickness or 450 mm. 3 times the thickness is equals to 450 mm. The smaller of the two, it will be 400 mm. As long as the spacing here is less than 400 mm, that means the maximum spacing is not exceeded. Same applies to this. 3.5 times the thickness is equals to 525 mm. The smaller value of the two, it will be 450. As long as the spacing here is less than 450, that means it is acceptable. Then you need to remember these two values. Because later when you do the curtailment, the area of reinforcement bar will be reduced by increasing the spacing of the reinforcement bar. As you increase the spacing, make sure the spacing does not exceed the maximum bar spacing. Now let us proceed. Since we do not need to calculate the stress in the reinforcement bar, you can ignore on this part. Now we will need to look into the amount of reinforcement bar provided after the curtailment. By referring to the simplified rules here, you are allowed to reduce the reinforcement bar by 50% near to the support, having the reinforcement bar provided here. How do you do it? Very simple. You look into the spacing of the reinforcement. Reducing by half of the amount of reinforcement bar, it will be equivalent to increasing the spacing by double. The spacing of the reinforcement bar at the midspan is 50 mm. Towards the support, some of the bar being curtailed. Every 2 bars, 1 bar will be curtailed, leaving you the spacing of 100 mm near to the support. Calculate the cross-sectional area of the reinforcement. It is just half of the amount provided. Now you know that you need to provide H10 100 mm. You need to determine the locations where you're going to have the reinforcement bar curtailed. We are talking about 0.1 times the effective span. And if you are talking about the shorter span, that means we are referring to this 3 meter. 0.1 times the 3 meters, that means this distance, it will be equals to 0.3 meters, which is 300 mm from the support. And then you can do the same for the secondary reinforcement. You may adopt the same principles here. Given the spacing 200 mm, you want to reduce it to half. That means you increase the spacing to 400 mm. Every 2 bars, you curtail 1 bar. That gives you H10 at the spacing of 400 mm. Calculate the amount of reinforcement. It is half of the provided bar area. And then you need to determine where the reinforcement bar should be curtailed. Since you are dealing with the secondary reinforcement, you are referring to the longer span, which is 6 meters. 0.1 multiplies 6 meters, you get 600 mm from the support. Ultimately, this is the amount of reinforcement bar after you've done the curtailment. Now, if you find it difficult to imagine how the reinforcement bar should look like, you may refer to this diagram. Let's say this is the slab, which is simply supported on the beam at all 4 edges of the slab. The longer span is 6 meters and the shorter span is 3 meters. If you draw a U line, it will look something like this, representing the directions how the slab will bend. That means the critical directions, it will be on the shorter span. Because of the bending directions, you know that this will be the main reinforcement. Where else, this will be the secondary reinforcement. Let's say we remove the secondary reinforcement first. This will be the layout of the reinforcement bar in the shorter direction. At the midspan, you have more reinforcement, which in this case, it is H1050. And then near to the support, you do the curtailments of reinforcement bar, one for every couple of the reinforcement. Initially, the spacing is 50. Now the spacing near to the support is 100. Double the spacing. Where do you do the curtailment? We are talking about a distance from the support, which is 0.1 times its effective span. The effective span is 3 meters, center to center. The distance to the curtailment, it will be 0.1 times 3 meters, which is 300 mm. Next, you will do the same for the secondary reinforcement. Every 2 bars, you do 1 curtailment. Now, the effective span in the secondary bar is 6 meters. Do the curtailment at 0.1 times the effective span. That means this distance, it will be 600. At the end of the day, you will see the reinforcement bar, something like this.